Given f of x equals negative x squared plus 1 and g of x equals 4x plus 1, solve f of x greater than 0. So I'm only going to use the first one for this problem here. So I'm just going to use that f of x equals negative x squared. And what I'm going to do is I'm just going to simply graph it. So now, keep in mind here, this negative on the front of it means that it's going to reflect across the x. So it's going to open downward. And then the plus 1 here says I'm going to shift up 1. Now again, I have no multiplier on my x, so on my x squared I should say. So that means when I go to the left 1, I go down 1 because it's downward. And then when I go to the right 1, I go down 1. And that's my first point. And then when I go over 2 on the left, I'm going to go down 4. So that's going to put me here. And then I'm also going to be on the other side too. And I could look at that because of the simple symmetry, because the equation of the axis of symmetry is the y-axis there. And I'm just going to keep going. I'm going to go a few more out here. So now I'm going to go, if I go 3 out, I'm going down 9. So that's going to put me here. And it does make the symmetry really nice because it's on the y-axis there. It's very handy. And then that's it. So I can draw this parabola now. I can do a little better than that. Try to make sure you go through all your points to some degree. All right, so there it is. So now what I'm going to do is I'm just looking where my f of x is greater than 0. So that means my y value of my f of x is greater than 0. And that's where I'm above the x-axis, which puts me in this piece right here. Now what I need to do here is I need to figure out what that interval is. And I know what it is already, just because when I graphed it, made it really easy to do. I know the solution for this one's going to be from -1 to 1. And notice I'm using parentheses. And the reason for that is because this is an equal to as well. It's just greater than. So that means it cannot be the n values. So where is it bigger but not equal to? And that would be above the x-axis specifically. Okay, let's take a look at the next one now, number B here. This says f of x is greater than g of x. Now, initially we can handle this algebraically to kind of get an idea of what's going on. Actually, we could probably get the whole idea just doing this algebraically. So I'm just going to sub everything in here. So first off, I have this f of x. And that f of x is greater than g of x. So my f of x is negative x squared, and I'm just going to put it in place of it, greater than, and my g of x is 4x plus 1. Now I can just solve this, so I'm going to add x squared, subtract 1, add x squared, subtract 1. And I'm doing it to the right side here so I can keep my x squared positive. It makes it easier if I factor or something to see the factors without the negative there. And that would be plus 4x, and that would be less than 0. So now what I'm going to do is just factor the polynomial there. And that gives me a lot of information. So if I pull an x out here, this is just going to be x plus 4 less than 0. And that tells me what's going to make this 0 here for this function. And I can see that that'll happen where x is 0 or x is -4. Hopefully that's okay with you as well. Okay, so that's where this is 0 at. So now I have to determine where f of x, which is the quadratic function, is larger than g of x, which is the line. So now I'm just going to graph them both to the right. This gives me a lot of information to work with this algebra I did here. And that's what we're going to do now. So I'm going to have to adjust my graph a little bit because I know I didn't go down far enough here. So I'm just going to make that adjustment. Okay, so there's the picture there. It kind of gives us a really good idea of what we're looking at now. And I try to be pretty accurate here, and it kind of worked out pretty good. Because I know that at -4, these intersect because we solved this inequality here, and essentially we looked at where they were equal to 0 at here. And that gave me 0 and -4. So at -4 is where they intersect, which is here. And I don't know what that y value is, but it would be easy to find out. All I would have to do is plug it into here. So if I plug that -4 into there, that's going to be -16. Plus 1 is -15. So it's quite a ways away. That's why I had to extend the graph, I guess. So this point right here is -4, -15. And the other point here is going to be 0, 1. So those are the points of intersection. And again, to find that, I would just have to set f and g equal to each other, and I could find out where they intersect. And that's okay, but that's what the points are. So now when I look at the question at hand here, my f of x, and my f of x being the quadratic function, so that's the blue one here. So my f of x is the blue one. And so I'll call it f of x. And the purple one is my line, which is g of x. So what I'm going to do here is I just want to determine where my f is bigger than my g. And that's where my y values for my f are larger than my y values for my g. And say I pick the value -2 here, and I just looked at where the y values on those functions are. So first I would look at those points, and I can clearly see the f is above the g there, which tells me there the y value is larger on the f there than it is on the g. So that happens on this entire piece right here. That's why I had to extend it. So it happens on that piece there, and that piece goes from -4 to 0. Because remember, it's my x values that I use to describe most of these types of intervals. So that would be from -4 to 0. Now again, this says just simply greater than, so I'm not saying equal to there, so I can't include the n values. So I'm going to use a parenthesis, and it's going to be from -4 to 0. And that's going to be my interval for which f of x is greater than g of x. Now another idea we can use here is I can actually plug in values here for x. And again, it has to be less than 0. So what that means here is I know 0 is where they intersect, and -4 is where they intersect. So I can think of this in terms of a number line here, and I can just put -4 on that and 0 on that, and I can pick values to the left and to the right of that. So for instance, I can pick a -5. Let me write it in another color. All right, let's go with this one. So -5. So when I plug in -5 here, this is going to be a negative, and this is going to be a negative, and a negative times a negative is positive. So that would be a positive there. So between 0 and 4, I can pick -1. And if I put a -1 here, that's going to be positive. And that's going to be negative, and a negative times a positive is negative. So that would result in a negative number, and that means it would be less than 0. So therefore, this would be a negative. And then for the last one, I can pick 1. Now here, 1 is positive, so they're both positive. Now think about what I'm looking for. I'm looking for where I'm less than 0, so it's where I'm negative. So if I look at the interval where I'm negative, it's going to be from -4 to 0. That's another way to look at what's going on here besides graphing it. I can simply use a number line for this. Now if this said greater than 0, I would pick the pluses, those plus intervals. And if I had to do the plus intervals, it would be from -infinity to -4 and 0 to infinity. That's how that would work, but this problem wasn't that way. So that's just another way to get to the same result. So there's our answers.